At typical high school, 60% of students like dancing. Well, we need to be careful to introduce some notation so that we can keep track of the information precisely and accurately. So here I'm gonna use I see a like dancing, so I'm gonna let D be students like dancing. Obviously 60% like dancing, therefore I do know that probability of D is 60%. And the rest dislike it. Dislike it because D is like it. D bar means dislike it. Dislike dancing. Which means probability of D bar is 0.4. Let's continue to read. Of those who like dancing, in other words, we already given that the people we are looking at, they're from this group, like dancing. 80% say they like it, so I'm gonna use L to represent say like it, which means L bar will say dislike it. When you see of those who like dancing, that means we already know that this group of people, they are coming from the like dancing, right? And then they say like it. So the given condition is we know that they like it, and then at the same time they say they like it. So therefore this is 0.8. With that, we do know that therefore probability L bar, I need to move it down a little. So probability L bar given D will be just 0.2. Let's continue to read. And of those who dislike dancing, 90% say they dislike it. Therefore, from here we do know of those who dislike dancing. So out of those D bar, we do know L bar dislike, right, is 90%. Which means probability of L given the D bar is going to be 0.1. Let's take a look at what we are trying to find. We are trying to find what fraction of students who say they dislike dancing actually like it. So which means we already know that they say dislike, and we want to find the percent out of those who say dislike actually like it. Using the notation that we introduced, that means we want to find given they say they dislike it but actually like it. That's what we are trying to find. A little background we need, prerequisites that we need. So first of all, we will need that this is the conditional probability. Probability of A and B is equal to probability of A given B times probability of the given condition, which is B. It depends on, this is another version. If you think of this as probability of B and A, right? So it can be written as B given A times probability of A, so either one. The second one that we need is the so-called total probability. The idea can be explained using this graph. So what is probability of A, which means this is the A, this little ellipse, circular shape is A. How do you find probability of A? It can be found by adding each intersection. If B1, B2, B3, they are mutually exclusive, and the union of the B's make up the whole sample space. So its probability of A is equal to this portion, which is A and B1, plus the intersection of A and B2, plus intersection of A and B3, and so on and so forth. If you have more than 3, then you just keep adding the intersections. Now, let's go back to the problem. So we have those given information, and let's begin with probability of D given L bar, right? Now this is equal to probability of D and L bar, the intersection of D and L bar, divided by probability of L bar. This result can be quickly derived from here, right? What is probability of A given B? It's equal to probability of A and B divided by probability of B. So I'm just using that idea. Probability of the intersection of these two divided by probability of the given condition. Now this is equal to, how do we find the probability of D and L bar? Now this is how we find the probability of intersection. We're gonna say this is equal to probability of L bar given D times the probability of the given condition, which is probability of D, divided by probability of L. Now how do we find probability of L? Okay, now we are gonna use this idea, okay, this idea. So it is equal to probability of L and D plus the probability of L bar and D plus the probability of L bar and D bar. The reason is just D and D bar, they are mutually exclusive, and the union of D and D bar make up the whole sample space, like dislike it and like it, dislike dense and like dense, they make up the all possibilities, right? Now let's continue. So this is probability of L bar given D times probability of D, and for the bottom one, for this one we just repeat the idea like this idea, right? So how do we find that? This is gonna be probability of L bar given D times probability of D, which is the same as this guy. They're actually the same thing, right? Plus probability of L bar given D bar times the probability of D bar. By the way, this actually is called the Bayes theorem, or the Bayesian's rule, the Bayes rule. This actually is, sometimes we just call it Bayes rule, in two categories. Now we actually have all this information available. They're all summarized up here. Probability of L bar given D bar, that's L bar given D bar, which is this guy. Probability of L bar given D, not this one, this one. So we just need to look up the information carefully. So this is going to be 0.2 times probability of D, which is 0.6 right here, and then divided by 0.2 times 0.6 plus, okay, now this is L bar given D bar, which is this guy, times probability of D bar, which is this guy, right? So therefore we have 0.9 times 0.4. This is 0.12 over 0.12 plus 0.36. This is 0.12 divided by 0.48. And we certainly should find that, which is 1/4, right? Which is this guy, 25%.